Hello Year 10. Today we are going to do simplifying expressions. Now what we're going to be doing from now on is you will have 2 lessons a week which are live lessons and 2 lessons a week which are recordings to watch and then worksheets to do. When it is like this and it's a video with a worksheet, it will be skills that you have already learnt to some extent but that Year 10 requires that we recap. So they should be easier things for you to do with a video, and then the live lessons will cover stuff that would be harder for you to do with just a video and a worksheet. However, if you struggle with anything on the recorded lessons, then either email me or make sure you ask me about it in the next live lesson. So, simplifying expressions. We talked about expressions last week. An algebraic expression involves all sorts of things, including variables or unknowns. No, not unknowns. Sorry, expressions cannot have an unknown because you can't solve them. Expressions will have variables or generalized numbers. They will have terms. They will have operators. And when an expression has terms which have the same variable with the same power, we can usually collect them together. So, simplifying expressions, first thing, collecting like terms. I am sure you've done this before, so I'm just going to do an example for you, and then there's quite a lot of questions for you to do to practice this skill. So let's say we have the following expression. If we wanted to simplify that by collecting like terms, we need to look for terms which have the same combination of variables or numbers, but it doesn't have to be the exact same number, and the same powers of those variables. So for example, this term has x in it. This term also has x in it, but it has x squared, so it's not the same power, so these are not like terms. This term also has x in it, but it has a y in it as well, so it is not the same combination of variables as this one is. This is just x, so this is not a like term either. 7 has no x in it. 4x. A coefficient doesn't make it not a like term, so if it's got a coefficient, that's absolutely fine. This really has 1 in front of it, so we'll be able to add the 2 coefficients together, and that simplifies to 5x. This one has an x in it but also has a y, so it cannot be collected with this one which just has x, and then this is just a number at the end, or a constant term, and we cannot combine a constant term with a term that has a variable in it. X squared, this is the only term with an x squared in it, so that doesn't actually simplify, it stays as it is. We've got yx, and then we've got xy. Now, because of the commutative law, multiplying y by x is the same as multiplying x by y. So we could actually rewrite this term here as xy, and then these are like terms. And again, this really has a 1 in front of it. So that's 1xy plus 2xy, so that simplifies to 3xy. Then finally, we've got the constant terms. We've got plus 7, minus 3, so altogether we have a plus 4. So this expression simplifies to 5x plus x squared plus 3xy plus 4. That should be enough explanation for you to have a go at the questions from exercise 1. So please pause the video and make your way through those questions. If you get stuck, please comment on Show My Homework and let me know, and I will either record a video to help you, I will comment to help you, or I will go through it in the next lesson. So you are now doing exercise 1. The next part of simplifying expressions that we're going to do involves multiplying variables together. So, as an example, if we had b times b times b times b as an expression, we could simplify that by grouping the b's together and having b to the power of 4. Another one, if we had 4a multiplied by 5b, the coefficients can multiply together because of the commutative law. That's really 4 times a times 5 times b. We just don't write the multiplication sign between algebraic terms. And then commutativity of multiplication, we can swap the a and the 5. 4 times 5 is 20. Times a, we don't need the multiplication sign. Times b, again, we don't need the multiplication sign. So our answer is 20ab. Last one, 3a times 6a. Again, because of the commutative law, that's really 3 times 6 times a, which gives us 18, and then a times a squared. Final example, some expressions may be given as a power of a term. So here we've got the term 3x, and then that term is squared. Using laws of indices, that means we need to square everything that's in the brackets. And so we end up with 9x squared. Another example, if we had xy squared, and then that term was squared, we have to square everything in the brackets. So we'll have x squared, and then we'll have y squared squared. Indices laws again. If we have a power inside and outside of the brackets, we multiply them together. So we'll have x squared y to the 4. That should be enough for you to have a go at the exercise, the second exercise on the worksheet. So please have a go at both of those. I will put the answers up so that you can mark your work, and then please submit your marked work via Show My Homework. We will then have a live lesson tomorrow, so Tuesday. You'll have a recorded lesson again on Wednesday, and we'll have a live lesson on Thursday. So my plan at the moment is that you'll have video lessons Monday and Wednesday, and live lessons Tuesday and Thursday at your normal lesson time. Any questions, leave a comment on Show My Homework.